Hi, this is Dr. Anthony Revis with Watch Me Work It. In this when we're going to name some compounds and look at charges. Okay, here we go. Well, here it is, and let's start with some ionic compounds. These are ionic because they're group one and on the one or two on the left side of the periodic table with typically group 16, 17 on the right side of the periodic table. So they're known as ionic compounds. So let's see how we made these. Let me spell it correctly for you. Ionic compounds. So here if I told you that we had a sodium with a plus and chloride with a minus, so always write the plus part of every compound followed by the minus part. That's how we do it. And these are the charges. Typically you don't write the ones, but we'll write them here for instructive purposes. So what we do is we will take these to make the compound. We'll take the charges. It's chlorine I'm trying to write. And we will crisscross these charges and we will make sodium 1, chloride 1, but we don't ever write the ones. So this is sodium chloride. If I told you that potassium had a plus 1 and bromide must be bromine has a minus 1, then you know how to crisscross those now. Crisscross them and just don't write the ones. And so we get that. If I told you that we had calcium as a plus 2 and nitrogen as a minus 3, you say, where did I get those from? Well, I gave them to you. Trust me for it right now. That's where they came from. I crisscross, and now I can get calcium. The 3 would come here, and the 2 would go there. If I did the same thing with aluminum with a plus 3, I gave you that. I told you that. That's known to me. And oxygen is known to me as a minus 2. I crisscross these also, and I get aluminum. 2 comes over here, and 3 goes over there. And we can do the same thing for magnesium with phosphorus. And we would get magnesium with a 3 and phosphide. The phosphorus would take the 2. Here we would have aluminum with a plus 3 and sulfur with a minus 2. Again, these are givens. So I gave you these, given. Got it? So you would get aluminum with a 2 and sulfur with a 3. So these are given. When they're given, you simply crisscross them and you get your answers. And these are ionic compounds. They're just named according to the base name: sodium chloride, potassium bromide, etc. So what happens if I move along and get these what's called D group transition elements? We still have the same formats, always plus, always minus. That's absolutely every compound we write by convention. Not absolutely every one. There are some exceptions. And in time, you'll learn those. So here we go. Let's do this one. So when we do this, we have to remember that when we have this, when we already have a structure, we have to assign the negative side. This is based on standard. You memorize it, you know it, or you ask someone, you look it up. But this right side is calculated. You calculate it to make sure that the charges are neutral. So we assign this. This is known. That's what I just happen to know it. I memorize it. So that's a minus 6. Therefore, to make this charge neutral, this must be plus 3. So that plus 6, I'm sorry. Therefore, iron must be calculated to be a plus 3. And so if I want to name this, I would name the base first. That's what I would absolutely do. At least I won't miss that part. Iron sulfur becomes sulfide. And I have to tell it what that charge was on that with the Roman numeral 3. Why the Roman numeral? Someone thought of it. It's cute. They use it. They love it. It stuck. That is the convention. When it's a convention, we simply follow it. So here we have copper. If I told you that that was a minus 2, then the negative side is minus 2. The positive side must be balanced for neutrality. Therefore, this is 1 time. That must be a plus 2. I name it by the base, copper. And then that's copper and that's selenium. So I say selenide. And that's a 2. So I put in that Roman numeral 2 by convention. That's how we write it. Copper 2 selenide. In this case, if I told you the standard is minus 3, so this would be minus 3. Therefore, this must be electrically neutral. So plus 3, 1 chromium, therefore stands alone by itself. So this will be named by the base chromium. And the last part will be chloride. And in between it will be a Roman numeral 3. In this case, if I told you SO4 has a -2, which is sulfate, the negative side of this is at a -6. This is with a standard -2. Therefore, this side must be a +6 for neutrality. Therefore, this must be a +3. So if I want to name this, I would name the base first, titanium. And I would name this last part because I memorized it from a table somewhere, sulfate. And in between it, I must tell them that there was a Roman numeral 3. Okay. Now let's do a few of what was called covalent compounds. Okay. Ready for covalent? Here we go. For the covalents, in this case, we're going to write the formulas based on the name. In the case of this, we see we have sulfur. So I write sulfur. And I have oxide. So I write an O. But I notice here that I have a di. Di means 2. So I put it sulfur, 2 oxygens. Okay. And then the next one I have is, I could see I have silicon. So I'll just write it, silicon. And I have 2 oxygens called di. So I call this dioxide. Okay, and these 2 compounds have similar names. And that's it. Just happen to have similar names, not the same compound and not the same geometry. So here we have dinitrogen pentoxide. So I know I have nitrogen in this. And I have it to 2 of these, dinitrogen. And I have oxygen in this because I see that oxygen has been changed to ide. And I have penta means 5. Okay, got it? Just simply by reading it. That 5 means penta. So here we have what? Chlorine. ClO. Chlorine. How many do I have? I have dichlorine. Okay, and I have an oxide on that. How many? I have 7. So I'm going to call this heptaoxide. See how I did that? I squeezed it in, but that's how it works. In this case, I have nitrogen trifluoride. So that's nitrogen, one of them. Tri means 3 fluorines, not the 3 in front of it, it's behind it. Okay, the convention is this is written on the back side. Here I have nitrogen, but I have 2 of them, so I'll call it dinitrogen. You can use capital letters or small. It doesn't really matter. Dinitrogen, because I'm always starting sentences or finishing a sentence or finishing a sentence. And I have 3 oxygens, so I'm going to call that trioxide. Here I have dinitrogen pentoxide, dinitrogen pentoxide. Both have nitrogen and oxygen, but they have it at a different ratio of atoms. Therefore, it's a different compound. And look like I did this one twice. Boy, why would I want to do that? I'll tell you what, I'm not going to write it twice then. Here I have tricarbon. So that's carbon, tri, and sulfur di. In this case, I have disulfur, sulfur di, chloride, Cl di 2. All right. So there you have it. That's how we would go about determining charges and doing these. Oh, just want to show you how to do one charge then? Okay, how about that? Let's just show you how to do one. Let's say if I saw this, this one here, let's just do it just for kicks and grins. So if we have nitrogen, so we have N2O5, the standard is assigned as -2. Therefore, this side is minus what is it? -10. Therefore, for neutrality, this must be +10. Therefore, this is 2 times 5. So nitrogen here will have a +5 on it. Let's just do one more here. Let's do this N2O3. Oxygen is -2. Therefore, this is -6. Therefore, this must be +6. Therefore, this must be +3. So you see they can have different charges there. In the case of tricarbon disulfide, look like I like to pick all these with 2 charges. Okay. This one gets a bit more complicated. So you have to do some funny math. That's why I want to show you this one. Okay. So this, you have to do some other math that we'll show you at some other times. All right. So watch for these. These are tricky ones that I want to point that one out to you. We'll do that in another setting. All right. That's it. how to name these compounds and do the charges.